Okay, so for this example, we're going to investigate the basic arithmetics operations that you can do in C++. This is an intro, so there will be a lot more as we progress through our lessons. But at least for this particular example, we'll get to see how to do an addition, a subtraction, a division, and a multiplication. So those are your basic arithmetic operations. As we move forward and we add more examples, we get to do more processing of formulas, conversions, solving for various algorithms. But let's start with the basics. So at this stage, I have a file, a source code that I'm going to call example 7. So, and save it in as example 7. And it's a .cpp file. Let me save it. As you can see right here in the comment, I wrote my basic objective, which is basic arithmetics, okay? So we're going to look at what we call operators. And the operators we're going to look at is the addition, the subtraction, the division, and the multiplication. So notice how these operators are written. Okay, so plus, minus, /, and the asterisk for multiplication. Okay, so those are your basic operators for basic arithmetic operations. We're going to do all of the work within the function main. Eventually, when we have more complex let's say formulas to solve and things of that nature, and we want to reuse the code, we're going to put that in separate functions. But right now, everything's going to be under main for the sake of simplicity, okay? So now, well, let's start with the plus operator. How do we add two numbers? Basically, that's what the plus operator, right, is for, right? So the addition. Now, there are several ways you could do this. It depends on your program. Do you want this to be a runtime program, a compile time? Which means how are you handling the variables that you're going to need for the input operation and the output? Which means if you're going to add two numbers, where are those two numbers coming from? And where's the result going back to? Okay? Now, you could have three variables for each. One for the first number, one for the second number, and one for the result. And then you're going to decide what kind of data type is that going to be. Well, again, are you doing, let's say, an integer addition or a float addition? In the real world, most likely, let's say you're doing physics, chemistry, you're measuring a house, you're doing all sorts of measurements with instruments, then that would be a float addition, all right? Now, if you're adding a sequence of time versus another one without a decimal point, that could be an integer addition, right? So let's say you have 5 apples and you're adding another 2 apples. Again, that's an integer addition. Unless you're allowed to, pull a knife and cut an apple in pieces, right? Then that would be a float addition. Right, so 2.5 apples plus 3 apples, that would be a float addition. So keep that in mind to decide how you're going to declare the variables that you're going to use. They have to reflect the nature of the data that you're handling. Okay, so let's do an integer addition for now. So let's say I have int num1, num2. Now notice these are my variables. They're of the same type. I am not initializing them. I am just declaring them. And then result. Semicolon. So if they're of the same type and I have 3 variables, you can list them with a comma separating them. So this is equivalent to saying int num1, int num2, int result. Okay? Each one in a separate line followed by a semicolon. This one here, you could write it all up in one line. Okay? As long as you're not initializing. Now, could you initialize while writing it in this format or style? Yeah, but I am not. My objective here is to keep it simple. So we're not going to look at convoluted code. So I have 3 variables that I need. They're of type integer. If they're integers, that means they're whole numbers. There's no decimal point, right? The intent is to add 2 apples with 3 apples or something of that nature. Now it's a matter of deciding where are the values coming from to populate num1 and num2 if you want to add them up. Okay? Now you could do something like this. Num1 equals 7. Num2 equals -2. You can. Negative number is perfectly fine. Okay? And then you could say something like this. Result equal num1 plus num2. Okay? Now remember, an addition is permutative. So that means you could have written it as num2 plus num1. Okay? The result will be exactly the same. And which means now you're going to add 7 plus -2. Right? That would give you a +5, right? Or a +5. Okay, well, can we display these values? Can we actually do this? So can I do something like this? Cout. And I could do something like this maybe. Num1 now notice this is a string. This is not the operation. So the operation really happened in this line. This is where you use the operation, right? So this is where you add, the add operation happened. Right now, you're not adding anymore. This is just a string. It's going to print that plus to the screen. But it will print what's inside of num1, okay? So you could do it this way, and that would be num2. And again, the equal is again an operator, right? So that means whatever is on the right-hand side now gets moved to the left-hand side. That's what the operator equal. So let me just add the operator equal to my list here, since it will be part of my basic arithmetic operators. Okay? And we've seen it before as an assignment. Now we're seeing it as a part of or the result of an operation. So that means whatever value gets added in here gets assigned to result. Now, I am simply printing it. Now, this equal that I'm writing here is not, okay, an operator. It's simply a string that's got a blank equal blank. So it's just to print to the screen. And then I could put something like this, result, and then end the line. Now, let's see what this looks like. So let me compile and run. Okay, and as you can see, I get 7 plus -2 equal 5. Now let me make this a little bigger so you can actually see this. And let me just go to 36 is good. There you go. Fantastic. So we've got 7. So we looked at the content of num1. That plus you're seeing there is simply a space plus space, whatever I have between the 2 quotes. So this cout statement is really a dumb statement. It simply does not process, does not do anything other than peek into the variable, retrieve its information. So what did it peek into? It peeked into num1, it peeked into num2, and it peeked into memory for result as well. And it printed what's in them. Okay, now this is one way to do operations, but it's not the only way. Why? Because this means you assigned 7 and -2 when you wrote the code. That could be problematic if you want an interactive program. Can we reuse num1, num2 in a more interactive program? Absolutely. Right? So we could do something like this maybe. Cout. Enter a value for num1. Semicolon. Don't put an endl, so the prompt will be right there. And then cn num1. Now we're doing what we call runtime, which means when the program runs, it will ask you for a value to store in num1. Now we've seen this example from the previous video, right? When we did an interactive program. So we're going to do the same thing for num2. So cout, enter a value, and to be precise, say an integer value, so the user does not make the mistake of entering a float number, for example. Otherwise, as you notice in the previous video, it will truncate it for num2. And then close the quote, semicolon. So this is, again, a string that's printed out to the screen, right? It's a string literal. And then cin num2. Now you could see that through these lines of code, I was able to assign a value to num1 and assign a value to num2. Now, what are you going to do with it? Well, you could do the same thing. You can reuse the add operation, result equal, result equals num1 plus num2. So you can repeat the operation. And can I print it? Sure, I can copy this code that I have here, right? And paste it right here. And I'm just going to call this one cout runtime. It's one word, really. Runtime example /n. And you know what I can do? No need for cout, since it's going to be the same line, right? So I am formatting my output, right here. So no semicolon here. Notice that. So what's going to happen? It's going to print runtime example, and it's going to put what we call an escape character at the end here, which will give you a hard return. So no end L here, okay? So /n within the string itself, it will create that /n or your hard return. Then what you're going to get at the bottom of it is the same thing you had here. So can we do something similar here? And we're going to call this one compile time, cout. And this would be compile time. Okay? Now, on this one, I'm just going to put end L. So you get to see two flavors. So you could have two distinct cout statements, or you could have it all done in one cout statement. Okay? So now you've got two flavors of how to do this. Again, you could write it out as one cout statement, compile time. This is what you get. So compile time means num1 and num2 were assigned values when you wrote the code, and it got compiled with it. Versus runtime means while the program is running, you will be asked to assign values for num1 and num2 and then see what the result looks like. So let's go ahead and do that. Compile and run. And notice I made a boo-boo somewhere. So it's saying, notice I have an extra N there. So it's a cout, not a count, okay? So let's go ahead and recompile. Compile and run. Perfect. Now, notice what it's doing now. So let me just move it right here so we can compare it to our code. So the compile time, as you can see, your header or your heading showed up there. Plus you have your numbers being added up. Your 7 and your -2 came from the code itself, right? 5 was deduced by adding these two numbers. Now I am in the runtime mode where I'm being asked to enter a value for num1. So let's enter -1. And then it will ask me for enter an integer value for num2. Well, fine. I'll enter a -4. Now remember, -1 plus -4 is going to give you a -5. Well, let's see if that's true. And sure enough, runtime example, -1 plus -4 equals -5. So I conclude this video right now. So the next one, or the next example, I'm going to go through the subtraction, the multiplication, and the division. So we're going to go a little faster. We're going to do examples that are runtime and compile time. Okay? And then when we're done with the basic operations, we will get into something interesting where what if you wanted to do something like square root, or you wanted to do raise something to a certain power, or if you wanted to do some trig like cosine and sine of an angle. How are you going to do that? Well, luckily there are library files you can use. And in our particular case, there is a math library file that we can use to help us even further for operations that we can't necessarily right away code ourselves. We could actually reuse some of the code that was standardized in these libraries for us to use. Okay, so and that will give us will let us to introduce ourselves to the standard library for C++. Now we've seen IOStream in a way. Notice the include statement above there, and that's for you to be able to use cout and cin. So we would like to see more and gain more capabilities.